This video lecture is in continuation to our previous video lecture wherein we were studying about the structure and properties of diamond and graphite, and we completed till this point where we studied that one layer of graphite, right, can easily slip over the other layer, right? Why? Because the distance between these two layers, right, is more than the bond length distance, right? Distance between the two layers of graphite is more than the bond distance, which is 1.42, right? So we have weak van der Waals force of attraction between these two layers, right? Because they cannot form normal carbon-carbon covalent bond, so we have weak van der Waals forces of attraction between these two layers, right? And this weak van der Waals forces of attraction make it less denser than diamond, right? So if a question is asked, why is graphite less denser than diamond? It's because of this weak forces of attraction. It is, to be precise, to be exact, because of weak van der Waals forces of attraction between the layers, graphite is less denser than diamond, right? And it is due to this weak van der Waals forces of attraction that one layer can easily slip over the other, right? Since one layer can easily slip over the other due to weak van der Waals forces of attraction, we say that graphite is slippery in nature, right? This nature of graphite wherein one layer can slip over the other layer, right, due to weak van der Waals force of attraction between the layers, right, make it slippery in nature, right? And because it is slippery in nature, graphite is used as a lubricant, right? So let me just write it over here. Graphite is used as a lubricant, right, because of its slippery nature. So first is graphite is used as a lubricant, right, because of its slippery nature, right? And why it is slippery? Why it is slippery? It is slippery because of weak van der Waals force of attraction between layers of graphite, right? Between these layers of graphite we have weak forces of attraction due to because of which one layer can slip over the other. So these kind of structure wherein one layer can slip over the other due to large distance, right, between the layers, it form what we call as layered lattices. It's layered lattices, right? So graphite has a layered lattice structure, right? Now it is less denser, we have discussed this already, less denser, it has density is less than diamond, right? Again because of weak van der Waals forces of attraction between the layers of graphite, right? And we know it's a good conductor of heat and electricity, right? Good conductor of heat and electricity. Why? Because each carbon atom in this layered structure is sp2 hybridized. Since each carbon atom is sp2 hybridized, due to which only 3 of its electrons are used in making or in forming bonds with neighboring carbon atoms, right? One electron is always free, right, which is mobile electron. That one electron which is not used in bonding with other carbon atom is a free electron, right? So in every layer we have free electrons. That makes it good conductor of heat and electricity, because we need electrons for electrical conduction, to be precise, mobile electrons for electrical conduction. So it has mobile electrons, so it is used as, so it is a good conductor of electricity, right? So all the points are almost covered, right? And these structures are important. Please go through this one and the previous lecture, right? Because this is part of previous lecture only, so make sure you just go through the previous lecture on structure of diamond and graphite, right? And melting point, sixth point, melting point of graphite is high, right? It's less than diamond, right? Little less than diamond, it's 3600, and melting point of graphite is 3500. We know that graphite also consists of strong carbon-carbon covalent bonds, right? So every layer has a network of covalent bonds, carbon-carbon covalent bonds, due to which it has high melting point, which is 3500 degree Celsius, right? So this is it. And one more thing, since its layers can slip over one another, so due to which these layers between the system of layers in graphite, in structure of graphite, can easily be cleaved, right? Or the layers can easily be ruptured, right? Because they can slip over one another, so they can easily be ruptured. Make sure you understand this, the slippery nature of graphite because of these layers, and the distance between the layers is more than the bond length, right? And the force of attraction is weak van der Waals forces of attraction, due to which it has slippery nature, and due to its slippery nature it can be used as a lubricant, right? So I hope all this is clear regarding this for the structure of graphite and diamond, right? Thanks.